Hey everyone, so in today's video we're going to be going over Dalton's law of partial pressure. So Dalton's law states that the total pressure of a mixture is equal to the sum of the partial pressures of all the individual gases in the mixture. As seen in the formula here, P total is equal to P1 plus P2 plus P3, etc. So each gas in the mixture contributes to the total pressure as if it were alone in the container. So to solve Dalton's law problems, you'll either be given individual partial pressures and asked to find the total pressure, or given total pressure and sum of the partial pressures and asked to find the missing one. Now, for the second equation, sometimes you'll also be working with mole fractions, which will follow this second equation here. And I forgot to write it, but X gas is going to be equal to the moles of the gas over the total moles. Now with that said, let's try the first problem here. A container holds three gases: oxygen at 200 millimeters of mercury, nitrogen at 400 millimeters of mercury, and carbon dioxide at 150 millimeters of mercury. What is the total pressure? So P total is going to be equal to 200 plus 400 plus 150 millimeters of mercury, and P total is going to be 750 millimeters of mercury. Let's try another problem, a little bit different from this. A mixture contains 0.5 moles of helium, 0.25 moles of neon, and 0.25 moles of argon. If the total pressure is 800 millimeters of mercury, what is the partial pressure of helium? So for this equation, firstly, we're going to have to find the total moles, which is going to be the total moles is going to be 0.25 plus 0.25 plus 0.5, which is going to be equal to 1.00 moles. Then we're going to have to find the mole fraction of helium, which is going to be equal to 0.5 divided by 1, which is going to equal 0.5. And our step 3 is going to be finding the pressure of helium. So to do that, P of helium is going to be equal to 0.50 times 800 millimeters of mercury is going to be equal to 400 millimeters of mercury. So common mistakes to avoid: try not to mix units, make sure all pressures are in the same units. Forgetting to add all gases in the mixture, make sure you account for all the gases, and not using Kelvin when temperature is involved in related problems. Remember that for temperature, a safe bet is to always, for any gas related problem, convert it to Kelvin by adding 273 when they give you degrees Celsius. I hope this video helped. Thank you.